Hello, boys and girls. This is Mr. Kizik, and in this video we're going to be talking about basically the beginning of trigonometry here. So, if you are planning to move on to pre-calculus or algebra 3, you're going to need to know like what all this stuff means here. And everyone usually hears the word trigonometry and they're like, "Oh no, this is not good. It's going to be difficult. It's going to be hard." And it really isn't, as long as you just know these ratios that we're going to be talking about. So, what is trigonometry? Well, trigonometry has a prefix tri in it, so it is the study of triangles. So, what do they do? Well, they're able to tell us in any given right triangle here, if we know, say, an angle measure, we know what the ratio is of the sides of the triangle given that angle measure. That's where the sine, cosine, and tangent on your calculator comes into play. So what is sine? Sine is the ratio of the leg opposite of the angle to over the hypotenuse. So if I look here, sine of A, here's angle A right here. Which side is opposite of that angle? Remember, opposite means if I drew an arrow and I hit that line. So it's A over what's the hypotenuse? Well, that's always opposite a 90-degree angle, so C. Well, what happens if the ratio was in terms of angle B instead? Well, the side that's opposite of angle B is little b in this case here, but the hypotenuse is still C. That's the ratio for sine. Cosine, the ratio is the leg or the side that's adjacent to that angle over the hypotenuse. So the hypotenuse doesn't change, that still is going to be C. But what now adjacent? So if I did, I accidentally deleted that one here. Cosine of A. So here's A again. Now, which side is adjacent, or in other words, helps create that angle? These two sides here help create the angle. However, what do we say C was here? This side's always a hypotenuse, so that supersedes it. That's not adjacent. In this case here, B is adjacent to the hypotenuse. Cosine of B would be the same concept. If I look at B here, this would be A over the hypotenuse C. And the last trig function that we're talking about here is tangent. Why does it keep wanting to delete that one? I don't know. Tangent, the ratio is the opposite over the adjacent. Remember, this is always going to be a hypotenuse. That's never an opposite. That's never adjacent. Tangent of A would be the side that's opposite of it, which is A, over that's adjacent, B. And then tangent of B would be B over A. Notice none of these ask for the ratio of with angle C in respect to angle C. And that is because, well, it's opposite. It's C, but that's also the hypotenuse. So the ratios sine, cosine, tangent of C, which is what measure, 90 degrees, something special happens with that. So, and if you go into the math next year, you'll learn more about that. So it can be difficult to remember what is the ratio for each of these trig functions for sine, cosine, tangent. Well, there's this little mnemonic called SOHCAHTOA. Well, sine is equal to the ratio. What do you think O means in terms of what we just talked about? It means opposite over hypotenuse. Cosine, well, what do you think the A means? Adjacent over hypotenuse. Then tangent is going to be opposite over adjacent. So remembering SOHCAHTOA will help you kind of remember or determine what the ratio is for each trig function. So look at this here. We're just going to look at this today, so it seems like. we're going to look at the ratio of these different triangles. So for number one, they gave you all three sides. That's not going to be always the case for a right triangle, which we'll see in the next example, but they gave you all three sides. So sine of A. Here's A. This is what we're talking about here. What is the ratio of sine of A? Well, if I look right above, sine is the side opposite over the hypotenuse. So what's opposite? If I drew an arrow, it's 5 over what's the hypotenuse? 13. If you want, you could just label this side as the hypotenuse because that's never going to change. It's always hypotenuse, never adjacent or opposite side. All right, let's look at now cosine of A. Well, oops, sorry, we were still looking at A. So A is the side that's adjacent, so the side that makes up angle A, which is 12, over the hypotenuse. And then tangent will be 5 over 12. And that's it. You're not solving for anything. At least right now, we're not solving for A here. We're just finding the ratio. As it says here, give each trig ratio. So now let's look at C. So now we're doing everything in respect to C. So sine of C would be opposite over hypotenuse. So 12 over 13. Cosine of C would be adjacent, 5 over 13. And then the tangent of C would be 12 over 5. And that, ladies and gentlemen, is how you would find the ratio. And notice too, and this is something that you'll learn next year, notice how like the sine of A is the same thing as cosine of C, and the cosine of A is the same thing as sine of C, and then the tangent of each angle, they're the reciprocal of each other. That's something you'll learn next year why that is true. And if you are curious, you can always look it up of why that is true. All right, let's look at number 2. So notice with number 2, I have a side missing. So like when I do sine of W here, I don't just put, sine opposite would be 12, and this is the hypotenuse. Oh, there's no hypotenuse, so I'm going to put x, so 12 over x. No, you actually have to solve for it because it's a right triangle, and you're able to utilize, remember, the Pythagorean theorem to help you solve for that right triangle. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. So we did the quadrilateral unit, and c is the hypotenuse. Now in this case here, that's what we're trying to solve for, and then the other two sides are here. So 9 squared plus 12 squared equals x squared, and then you would just do the math here. So 9 squared is 81. 12 squared is 144 equals x squared. I would add up 2 here, so 81 plus 144 equals 225. So then I'm running around. So now I take the square of 225, which is going to be, it is going to be 15. So x equals 15. So this side here is 15. Now I can go about the ratio. So sine of W would be 12 over 15. But just everything we've done in math here, if you can simplify the fraction, do it. So 12 over 15 becomes 4 or 5. Now I do the cosine of W, so that's 9 over 15. And I can simplify, so that becomes 3 over 5. Tangent of W would be 12 over 9, which reduces down to 4 over 3. And I do the same thing, but in terms of x here. So sine of x would be opposite. 9 over 15, or 3 over 5. Cosine of x would be 12 over 15, or 4 over 5. And tangent of x would be opposite over adjacent, so 9 over 12, which is going to be 3/4. And that, ladies and gentlemen, is how you deal with trig ratios. And what I have here, I got a little less than 5 minutes. So, what I want want you to do is like you try number 3 on the notes right here. Remember, I'm looking for the missing side again, so I got to use Pythagorean theorem. But remember, what will the setup be? Will it be 16 squared plus 34 squared equals c squared? Or do I have the hypotenuse? And that would be my c, and then I got to solve for one of the legs. So that's what you have to figure out. And then you'll have to do the ratios for the rest here. Remember, if you have any questions or concerns, please feel free to message me. This is Mr. Kiesik, sign off.